today we will learn how to calculate the indices using remote sensing images, and the first and the foremost indices that is being used worldwide, that is NDVI. For different purpose it is being used. The expansion of NDVI is Normalised Difference Vegetation Index, and NDVI can be calculated on the basis of the reflectance in two bands, that is NIR and red. So first we will open the software. ENVI software is available with the computer, ENVI 4.7, and then we will open any image which is available at the local machine. Open image. The images are available in Drive app within PG Practical folder, and then there are different folders having different images. As we are mostly working with the Landsat data, Landsat continuity mission 08, we will open any file that is available within the subdirectory. In the previous exercises we had created the subset of Pantnagar region, so would be good to open that subset. So Pantnagar region subset, you can see there are 5 different bands available with this subset, and now we can display it in FCC, false color composite, and false color composite is when you are displaying NIR band with red, red with green, and green with blue. So band 5th in this case is a NIR band, band 4 is red band, and band 3 is basically the green band. Now load, and you can see that the image in FCC has been displayed. Because it is FCC, so vegetation is appearing here as well. I would like to draw your attention on the concept of NDVI. We had discussed in the past as well that over vegetation, the reflectance in NIR region would be quite high and the reflectance in red would be quite low. The red is heavily absorbed by the vegetation and it is utilized in the photosynthetic process, while NIR is highly reflected by the vegetation because of the space available within the cells, the arrangement of the cells, etc., etc. So that also means that over vegetation, the difference between NIR and red will increase. Now we will go to the basic tool, and in basic tool we will go to the band math, and in band math we will have to write that same expression of the NDVI. The expression or the equation to compute the NDVI is NIR minus R divided by NIR plus R. So the equation would be NIR minus R divided by NIR plus R. This equation cannot be written as such in this band math function, but you will have to write this equation in a manner so that computer and the software is able to understand what you have written. So we used to write this equation like this: float B5. B5 we are assuming here is NIR band, because NIR is the band 5, so we are writing is here as B5. But it is not mandatory that you will write B5, because no, at the later stage it will ask you to create the pairing of what you had written here and what is available in the image. That also means that even if you are writing here B1, so that B1 can be paired with the band number 5. But for ease of the understanding, we are writing here B5, just so that no, we will have in our mind, and it would be very easy for us to understand that B5 is the band number 5, which is the NIR band, minus float B4. So B4 here is representing the band number 4, which is red. So NIR minus R divided by float B5 plus float B4, and for ease of the understanding we can also place parenthesis both sides, numerator side and then the denominator side. So now your equation is complete. Here I had written here the float with every band name. The reason is that if you are not writing here float, then the software will understand it as integer, and then it will only read all the values available in the image as integer, and the output will also be the integer if you are not writing. But once you had written the float here, so it will read all the value as a float, and also the output which would be produced would be as a float. If you go by this equation, the theoretical range of NDVI is -1 to +1. -1 would be when the value of NIR is 0 and the value of red is maximum, and +1 would be when the value of NIR is maximum and value of red is 0. So these are two extremes which we had considered. So theoretical range will vary from -1 to +1, but the real range will be somewhere -0.3 to +0.7. Sometime it is even shooting up to 0.8, 0.85, but rarely. And the value of the NDVI is directly related with the value of vegetation. That means that if biomass is increasing, if leaf area index is increasing, the value of NDVI will also increase. So it is having positive relationship with the LAI, leaf area index. At initial stage it will have direct one-to-one relationship, but at later stage this will become saturated, and then with increasing LAI, the NDVI value will not increase in the same manner as it will increase in the initial stage. Now we will run this expression, say okay, and now what I was telling you that at the later stage you can pair. So even if you had written here B1, B2, it is asking you what is the meaning of B4 and what is the meaning of B5. And here on the bottom side, it has given the images, the different bands available in the image. So you can pair any band with this any band name. So B4 is basically the band number 4 we had assumed. So we will pair it with the band number 4. And band number 5, this B5 would be paired with the band number 5. Now your pairing is complete, and now you can store or you can save your output on the hard drive, or you can keep it in memory. We are saving on hard drive. NDVI. Say OK, and now you can see the fraction of second it has created another image with the single band, and you can see that the same expression has been mentioned, so that you can easily recognize what output it is. You can just choose it and you can display in this output into the new display, and now you can see this is the NDVI image. And you can also read the value of the different pixels just having this cursor location value window open, and when you will scroll or when you will move or navigate in this image, you will get to see the NDVI value here against the data. So you can see that these brighter regions, which are basically representing these vegetative regions, they are having higher values, and these darker regions are having low value, and very dark region, especially related with the water bodies, they will sometimes have the negative value, but we are not able to see it. Maybe we can generate the local statistics, quick stat, and then we will get to see whether there is any negative value or not. Yes, there is negative value. You can see the 1 pixel is having the value minus 0.011509, and then most of the pixel, only that 1 pixel, you can see 1 pixel is having negative value, and rest other pixels, the other pixel is this, all these are having the positive value, and the maximum value which has been recorded here is 0.5. So this maximum value will again depend on the season of the growth, the crop season, and within crop season the stages of the crop, like when the crop has attained the full vegetation, so the value of NDVI would be like 0.8 to 0.85, but if it is in the early stage, then the value would be little less. I'm closing it. You can also link these two windows. I had explained it earlier as well. Go to tool, link, and then you can see this, it should be on. Likewise, you can see, or if you want to see one image in another window, so then you can link it to the link display. Yes, and when you will press cursor in any image, so the other image like that. So then easily you can relate over vegetative regions, the value of NDVI is quite high. You can see this entire belt is having the vegetation, especially forest, and is having the quite high value. This is fallow field and is having very less value. You can see, and these darker regions are the regions with high moisture, and these are having further very low value. There is no region here where the water has been accumulated, so negative value only in one case has been reported, but it is difficult here to identify which pixel it is, where it is, right? That way you can calculate NDVI value. If you want, you can also display it in color. Go to tool, color mapping, and then go to ENVI color table, and when you will go to the ENVI color table, you will get to see the different options available. By default is black and white linear color table. This is the color ramp, so this has been by default selected, but then you can go to other color combination, and then your output would be displayed in color like this. This is one combination which is quite good, having the green, then red, and the white there, but if you see, the pattern is just opposite to the greenness pattern of the field. Green is at the lower side and the white is on the higher side. What you can do is you can just change this pattern, you can revert it by stretching this button to this extreme and stretching this button to this lowest point, and now this thing has been reversed. Now green is representing those regions with the higher vegetation, and white is representing no vegetation, and red is representing here the regions with the less amount of vegetation. So that way, you can also play with this, if you want, and having the different levels of the switch. Similarly, other color combinations you can see. This is another good combination, but the green is somewhere in between. The blue is having the maximum value in this case, like that. there is another green and white, so this could also be one good combination. Green having the maximum, white having the minimum value, right? If you are not convinced with this color scheme, you can also pick your own colors. Go to the color mapping and the class color mapping, the density slice. Go to the density slice, and in density slice it will ask you to put the input image, select it, say OK, and here you can see the classes have been shown here with the value and the color, and these can be modified. These can be easily modified. Well, let's say if you want to have 6 classes, 1, 2, 3, 4, 5, 6, so you can just have the 6 option, or what you can do is add it or delete any range from here. Delete one and delete another. So 1, 2, 3, 1, 2, 3, 4, 5, 6. There are 6 classes, and now you can modify. You can edit it. Add it. So the least value should be represented. Maybe the red one is okay. You can change this range, but it is starting from 0.002, then you can have here, because it was going up to 0.5, so maybe 0.1. So 0 to 0.1 you can say red, then add it 0.1 to 0.2, and the color can be changed from here. It could be red but not that dark red. Then 0.2 to 0.3, and the color could be maybe blue, cyan we can have, then 0.3 to 0.4, maybe blue, then 0.4 to 0.5, green, and then 0.5 to 0.53, or you can say 0.6. So that way you can edit, you can make your own color combination, own color ramp, and then you can apply it, and that way you can have your own color combination. In this case you can see the red is representing the region with the lower NDVI value, and this is clear because this is follower. Only these green patches and these blue patches, these are having a certain amount of vegetation. If you want, you can even further give this as well the green color, like cyan color can also be given light, maybe light green. You can also change this color combination from here like this.